Hello everyone, myself Chaitanya Gottipati. Today I am going to discuss a topic about applets and applications. In this topic I have created notes, so I will show you in later topics. So here in this topic we have to know about few things. Those are how to get a display and a scale image, and how to create animations from a sequence of images, and how to create image maps that can be seen when the cursor is over them. So as you all know, before we have discussed about what is an applet, and now we are going to discuss about applets and its applications. So what so in this chapter we are going to discuss more about these applet applications. Such as these applications I have already represented how to get a display and scale images, and how to create animation from a sequences of images, and how to create image maps that can seen when the cursor is over them. So all of these we can see in day-to-day life, day-to-day use. And if we go for a map, and if you represent a cursor on any point, and it will highlight the place or the name where you represented the cursor. So all these comes under the applets applications. And here there are two more topics that we need to know before we complete this topic. How to play loop and stop sounds using an audio clip, how to play video using interface player. So these are also some few applications we have to know. and I have to show, here is my notes. I have created myself to explain you in a brief way. And if any programs and any applications in this topic, I will show you by my notes. Okay. And coming to the introduction, and here the multimedia using sounds, images, graphics, animations and videos comes under which makes applications under the multimedia. So although every Java can do only two-dimensional, but nowadays everyone needs the three-dimensional in order to give a high quality resolution, HD quality video, animations and all the stuff. So and we can use Java 3D API to create the 3D graphics applications. But nowadays every smartphone comes with a default option of high resolution video quality, graphics and all the stuff. So nowadays every computer or every smartphone have these options. So these applet applications have become more updates and lots of changes in them. So mostly all of the devices are coming up with high resolution and high graphics, and with DVD ROM etc. features. And coming to these multimedia demands of the user, they are extremely high. So the user nowadays he want to he want to own a computer which can perform powerful and durability, and as well as he is giving more importance to the multimedia activities such as movies and graphics, gaming and all the stuff. Users are eager to own the fastest computer process to use the high graphics. So uh, pretty much if we observe in a market, graphics play a key role. So nowadays every user need a minimum graphics quality. So those are very high. So for that, instead of the Java API provide the multimedia facility that enable to start developing powerful multimedia applications. As per the example, we have the 4 points. Those the basics of a multimedia image: creating smooth animation, and playing audio field with audio clip interface, playing video field using player interface. So these are the powerful and basic things that user is very much uh, eager to have in a computer. And we also introduce additional JNLP features that with user permission. So with the user permission, nowadays the multimedia is introducing the JNLP feature that enables an applet or application to access a field on the user local computer. So because of this JNLP feature, the performance of the multimedia will be very high. And as we all know, the Java API is only for the 3D view, but with this JNLP feature, it can give you a high resolution, which will be the HD quality or the DVD one. So for more quality, there are some applications like Java Media Framework, JMF API. Java Media Framework, which is used to help for additional video media to an application, and Java Soundfly 3D graphics, which is used to give a high quality sound while the video is running on, and Java advanced images. These advanced images are nothing but to give a GIF, as we all see some GIF applications in the internet, and speech. Java Speech API and Java Image API. Java Speech API, the video recorder, the speech quality without any disturbance like sound cancelling and all the stuff. Java Image API, which will give you a high resolution. Even if you zoom an image, it will not give any blur, or it will not show you any low resolution of an image. So these are the more applications in applet. So here we done with the introduction, and moving on to what are the main features in these applications, and what is the programming coding for these applet applications. Loading, displaying, and scaling images. This is the next topic that we are going to discuss about now. And in this topic we are going to start with first images. So we can create our own image by some software such as Adobe Photoshop and Paint, Gameplay, so on. But while coming to applet, we can create Java Web Start and JNLP file open service to allow the user select an image that can display the image and allows the user to scale it. So in order to give a high resolution and best quality of an image, we are going to use an applet service, and we are going to use a JNLP file opener service to allow the user select an image. Then the display the image and allows the user to scale it. After selecting an image, applet gets that into the bytes from the film that pass them to the image constructor to create an image that will be displaying. So after selecting this imager, it will convert the image to the bytes file, then pass them to the image constructor to create the image which will be displaying in the applet format. And coming to here, that class image icons constructor can receive an arguments of servicer several different formats, including a byte array containing the bytes of an image and an image package, java.awt already loaded in the memory, or string, or an URL representing the image in the locations. So the located memory will or string, the URL representation will be supporting the Java format, including the graphic interface format, and join the photographic aspect group JPEG, portable network graphic PNG. So these are the some formats that will be helpful in applet in order to give a good resolution of the image. And these types are typically end with GIF, JPG or JPEG and PNG representatively. So coming to the class image icons, construction can receive arguments of several different formats, including a byte array and constructing the byte of an image. So bytes, arrays, and these are helpful to convert the image into the binary format. And an image package java.awt already loaded in the memory, or a string or a URL representing the image located in Java supports various images format, including graphical interface format and join photographic aspects, group JPEG, and a protocol network graphics interface. Name of these type of typically end with GIF. And so as we all know, in the internet we can see day to day GIFs and JPGs and JPEG or PNG representatively. So these are all comes under the these GIFs. These are all created by the applet application. So here coming to the code of the applet application, here we can see the code. So this is the code of an load image and scale Java, loading, display, and scaling an image in a applet. So this is a code for images that we can create through the applet. And coming to the here, I have shown up here line 24. Upon that, it will be continuing like this, and field text and private Java text field and scaling images and obtain user interface private. In order to see the code, I will represent from the first onwards one more time. So that is a code for that. So and then after giving the code, it will result in like this in our systems. Java abstract security dialog that appears because this applet is required access to a field on a local computer. So it gives a file like this, and then open a dialog that appears in the user click OK in the security dialog. So coming to this part, and it will show you like this. And you can go to the next step, and here you go, the image in the Java applet application. We can see an image which was created by giving a code, and you can see the scale percent, like 100% and 200%. You can see the difference in that. And configuring the GUI and JButtons event handler. The applet isn't method applet init method configure the GUI and an event hand user JNLP service to enable the user to select an image to display from the local computer. In the line 31 creates the J panel that will contain the J label, J text field, and J button creator. In the line 34 and 36 and 37 and 39, as I showed in the code, add these components to the J panel default floor Line 40 places the J panel in the north region of the applet default body layer. So line 43 and 54 creates the event handler for scaling change button, where the click the button. Line 49 50 obtain the user input of the scale input J text field, divided it by 100 to calculate the scale percent, and assign the result to this value will be used in later calculations to the scale image. For example, enter 50, the scale value will be 0.5 and the image will be displayed on the half of the line of 51, then represents the applet to display the image at its new scale. So here we discussed about the new scales and the buttons, and using the code we can configure the GUI event handle using JNLP service. So this is about event handler, which we can represent through giving some buttons and some options using the code. As I showed you the code before, so for the code we can represent this textbook. Open the image file using JNLP file opener service, as we mentioned in the section 23.7, which is showed in the before code. With the user permission, Java Web Start programs can access the local file system via JNLP APIs of a package JavaX and JNLP. In this example, we would like the user to select an image from the local computer to display in the applet. So in order to do this, the user should select an image and to display in the applet. We have provided two images in the example directly with the source code. We can use JNLP file opener service to request limit access to the local field system. In the line 7 and 9, import the interface and class we need to use the file opener service lines. So import the interface and the class we need to use in the file opener lines in the line 7 and 9. 6262 use the JNLP service manager class string lookup method to obtain to the file opener service. JNLP provides several service to this method returns that we must cast to the appropriate type line from 65 to 66 in the code. Use the file opener service from file dialog. If you want, I can show you the 65 to 66 line, and here it is shows that 7 to 9. Import the 7 to 9 line. So import these 7, 8, 9. Import the interface, the class we need to file opener service, and 6269 will be 6269 will be in. I'll try to open the 6269. So this is the line from 6269. We can use these commands to open the file for the new command. On 65 to 66, use the file service opener. When the user select an image file, then click the open button in the dialog. Once again, click the open button in dialog. Then then it tries to open a file, open an image, and then here coming to the next topic is displaying the image with the class, which will be the draw J panels and print the command methods. To separate the GUI from the area in which the image is displaying, we use a subclass of J panel named as draw J panel L. So as we discussed before, we need to separate the GUI from the code, so which is from the lines 83 to 102 in the code. its paint component method will be from line 86 to 101 displays the image. We would like to center the image in raw JPanel. So line 91 to 94, 91 to 94 calculate the difference between within width of the panel, width of the draw panel and that of the scaled image. Then the height of the draw panel and that of the scaled image. Draw panel get width and the get height methods. So from the line 91 to 94 will be the width and the height of the draw panel methods, and return the draw panel with width and the height respectively. The image icons or get icon, the image icons code will be the get icon width and get icon heights method. Return the image within the height. Representatively, the scale value is set 1.0 by default. Line in the code will be 26, and in change when the user click the subscale J button. Lines 97 to 100 uses the graphics methods to draw image to display a scaled image icon. The first argument invokes the image icons get image icons. The term will be get image method to obtain the image to draw. The second and the third argument represents the image upper left corner coordination with the represent to the draw panel upper left corner. The fourth and the fifth argument specify the image scaled within the height respectively. Line 99 scales the image within the invoking the image icons get icons. Those two are different methods, and these can be multiplying. It returns value by scale value. So get icons and the image icons are the methods which can be multiplying it return values by the scale value. So to simplify the line, we need to go through the code 100 scale and image height. The last argument in the image observer and interface implemented by a class component. Since class draw panel in indicatedly expanded component, a draw panel is an image observer. This argument is important when display is getting the larger image, then require a large time to load or download from the internet. It is possible then a program will attempt to display the image before it has completely locked or downlocked. As the image loads, the image observer receives notifications and updates that image on the screen as necessary. As it said that once the image is loaded, the image observer receives the notifications and updates on the screen if it is necessary, if it is useful. In this example, the images are being loaded from the user computer, so it is likely then entire image will be displayed immediately. So it says that image are being loaded from the user computer, and then it can be displayed immediately whenever the user want to open the file. Compiling the applet. This will be the next step after doing all the coding and all the stuff. Compiling and running this applet requires the jnlp.jar file. So compiling an applet, we need a jnlp and jar file that contains the jnlp API. This file can be found in your JDK installation direction under the directories. So here compiling an applet, it says that compiling and running this applet requires the jnlp.jar file. So this is a file that contains the jnlp APIs. This file can be found in our JDK installation directory under the directories. The directories are I am showing my notes. The directories are sample jnlp server to compile this applet, Java Java C slash class path project file and load image and scale Java. So this is a directory under the JDK installation file. And coming to compile, how to compile the applet, use the following command, which will be java c slash java path, which will be java c slash programming file slash java slash jdk and scale Java. This is the command which will be used to give the instruction, where path to JNLP JR file includes the both path and the file names. Path to JNLP and JR file includes both path and file names. JNLP.jr, for example, on our Windows Vista computer, the path to JNLP JR file is here. In JNLP JR file contains this command c slash program file Java, and so it consists of this command there. And packaging the applet of packing the applet for use with Java Web Start. To package the applet for so after completing this compiling the applet, coming to the next topic, it will be packaging the applet for use with Java Web Start. To package the applet for use with Java Web Start, you must create a JAR file that contains the applet's code and the JNLP.jar file. To do so, use the command, and the command will be JAR. I'll show in my notes, which will be JR CVF load image and scale dot jar. Coming to the class of it, class to JNLP jar file. So this will be the command for the packing the applet for use. These are the images which came as an output of that of the code what we have discussed before. And coming to the next topic. Coming to the next topic, which will be loading and playing our audio clips. Java program can be multiplied and play audio clips. Users can capture their own audio clip, and many clips are available in the software products. And over the internet, your system need to be equipped with audio hardware such as speakers and sound card to be able to play the audio clips. Java provides the several mechanisms for playing sound in an applet. The two simplest are the applet's play method and the play method of the audio clip interface. Additional audio capabilities are available in the Java Media Framework and Java Sound APIs. So the sample code will be like print void play URL locations strings such as file name, and public void play URL sound URL. The first version loads the audio clip stored in the file stored in the file such as sound file. From location, play the sound. The first argument is normally a call to applet to get the documents based or get code based method. So the sound engine that plays the audio clip supports a several audio file format, includes the Sun audio file format and a Windows Wave file format, and etc. The JMF and Java Sound API support additional formats. The program of figure 24.8 demonstrates the loading and the playing an audio clip. This technique is more flexible than applet method play. An applet can use an audio clips to store audio for a repeated use throughout a program execution. Applet method get audio clip has two forms that take the same argument as method. Method play, which plays the audio clip once. Method loop continuously loop throughout the audio clip in the background. Method stop terminates an audio clip that is currently playing in the program. Each of these methods is associated with a button on the applet, and here is a code for that. And this is the continuation code. Playing, and coming to the next topic will be a playing video and other media with Java Media Framework. A sample video can continuously and effectively convey a great deal of information using the Java Media Framework JMF API. You can create Java application that plays, edit, stream, and capture many popular media types. This section briefly introduces some popular media formats and demonstrates the playing video using JMF and API. JMF supports the media file types such as Microsoft Audio, Video, Intervals, and .avi. Micromedia Flash moves as .swf and Feature Splash as SPL, and Layer 3 audio files, and QuickTime movie players and audio files, and etc. Currently JMF is available as an extension separate from the JDK. The most recently JMF implementation can be downloaded from the oracle.com, and keep track of where you install the Java Media Framework. So keep track of where you install Java Media Framework on your computer. To complete and run this application, you must include in this path the jnf.jar file that is installed with the Java Media Framework. Recall that you can specify the class path with both the JavaC and Java commands via the class path command line option. The JMF website provides the various of JMF that takes advantages of performance feature of certain platform. For example, JMF window platform performs the peak previous extensive media, and the device supports for Java programs run on Microsoft Windows platform. The JMF web oracle.com and provides the information and resources for JMF programs. Creating a simple media player. JMF offers several mechanisms of playing media. The simplest is using an object that implements the interface player declares in the package JavaX Media. The package JavaX Media and its sub-package contains the class that compose the Java Media Framework. To play a media clip, you must first create a URL object that refers to it, then pass the URL as an argument to static method. Create realizer player of a class manager to obtain a player for a media clip. Class manager declares the utility methods for associating system resources to play and unto multiple media figures 24.9. So here this is the code for the JPanel that plays a media file from a URL. These are the codes for that. And this is a continuation code for the video. In this video we can give a GIF command, as we all see in the internet. So this is the code for the video, and this consists the line 15 to 51. Set up the JPanel to play the media file in in the line 15 to 51. It sets up the JPanel to play the media file specified by the controller URL parameter media, and manage lightweight readers. So a postulating slides to jump to create a point in media clips, a pause button, a volume button that provides the volume control by right click, and a mute function by left click, a media properties button that provides the detailed media information by left click. So line 37 calls the player method start to begin the player that media file. Line 39 to 50 handles the various expectations that create realized player throws. The application in the figure. This is the code that is given for the above topic. Method main player to play the selected media file. You must convert the file object returned by the JFile chooser to a URL function. Method to URI of a class file returns a URI that point to file on the system. So wrap up. In this chapter we learned how to build a multimedia rich applications with sound, images, graphics and videos. We introduced the Java multimedia capabilities including the Java Media Framework API and the Java Sound API. We used class image icon to display the multimedia images stored in the file, and also we discussed about the audio and GUI concepts and etc. Thank you. Packing the applet for the user with Java Web Start. So this will be the next one to the image of the applet. To package the applet for use with Java Web Start, you must create a JAR file that contains the applet code. And the jnlb.jar file. To do so, use the command jar and cvf. As I showed you before, code will be jar, cvf, and this will be the code. That will be the code, and where path to input the JAR file includes the both path and the file name jnlb.jar. This will place all the class file for the applet and a copy of the jnlb jar file in the new JAR file. Load image and the scalg.jar. JNLB document for the load image and the scale applet. The JNLB document in the figure 24.2 is similar to the one introduced in the figure 23.12. The only new feature in this document is that the resource element line 10 to 14 contains the second jar element. The resource line in the line 10 to 14, I will show you the code that refers the jnlb.jar file, which is amended in the file loadimage.scale.jar file. So this will be the code, and here it says that from line 10 to 14 and here it shows from line 10 to 14 it will contain the jar element, and the line 13 will be the reference that jnlb.jar file is, which is embedded in the file of load image and the scale jar. So coming to the next topic will be the making the applet draggable outside the browser window. The HTML document that loads the applet into a web browser. In this example, we use an applet element to specify the applet's class and provide two para element between the applet element tag and the line 4 specifies this applet draggable is a command that we can use a key that can be holded as alt key and use the mouse to drag the applet outside the browser window. So the applet will then continue with executing even if browser is closed. Checking the close box on the applet when it executes outside the browser causes the applet to move back into the browser window. If it's still open or to terminate otherwise, the second param element shows an alternate way to specify the JNLB file that launches an applet. So here it says that applet should be executed outside the browser. So firstly it have to be dragged completely. After dragging an applet from the browser window, it can still open and terminate the second param element. Shows an alternative way to specify the JNLB file that launches an applet. We discuss the applet parameters in more detail in this. For example, this is the code for JNLB file. From line 3 to 5 we can see the load image on the scale class within 400 height, and here the user gave the width and the height of this image, and in the line 4 and 5 it shows the param element which can be draggable, and it is represented as a value is true, and then parameter will be JNLB href value. So this is the command which which can run even if image is dragged out of the browser. So this load image and scale.jnlb is a code for that. So coming to the animate a series of images, this will be the next topic of the images. Next, we animate a series of images stored in an array of image icons. In this example, we use the JNL file opener service to enable the user to choose a group of images that will be animated by displaying one image at a time at 50 million intervals. So here this is the advanced concept of the applet images. In these animated images, the JNLB file opens a server which enables users to choose a group of images, and the user can select up to n number of images that will be animated by displaying one image at a time, the range will be up to 50 million second intervals. So the merging can be happen very easily. The animation presented in figure 24.4 to 24.5 is implemented using a subclass of JPanel class logo animator JPanels that can be attached to an application window, or a JApplet class logo animator declares a main method to execute the animation as an application method main declares to increase the class and source domain, increase the class frame and attaches a logo animator JPanel object to the JFrame to display the animation. So here will be the code for the animator logo. As we all discussed before about figure 24.4 will be implemented as a use subclass of panel. So this is a figure 24.4 code, and if we see here, it says the display dialog that allows the user to select the multiple files. File contacts is equal to file open service and open multiplier dialogs null command null. Hold on, new time and animation timer is running. Animator time is restart. So this is all the code for that. And then coming to the next topic. So here is the output. We can see this is the logo of the animator image. Class logo animator panel. Class logo animator panel maintains an array of image icons declared at line 16 that are located in the constructor line 25 to 61. That constructor begins by using the JNLP file opener services. Open multiple files dialog method to display a file section dialog that allows the user to select multiple files at once. We named our simple image such that they all have the same base name, that is title followed by 2-digit number from 0 to 29 command. This ensures that our image are in the proper order for the animation. As in this chapter, first example, the user is prompted to give the permission. Then the open dialog appears in permission is granted. File open service method open multiple file dialog taken the same argument as method that opens the file dialog but returns an array of file constructs object representing the set of files selected by the user. When you run this application, navigates to a folder containing the image you wish to use. Select the image. If you wish, you can use the 30 images we provided in the example subdirectory name images. In the line 39 creates the array of image icons that in line 42 to 51 populate the array by creating a byte array for current images, data reading the bytes of images into the array. The line 49 and creating an image icon objects from the byte array. In the line 54, it shows the by the line 54 of the code. It shows the many by the line 54 where width is equal to image into 0, get icon get icon. So by this code we can give the width of the array. And then coming to the method start animation. So the method which from here the animation will be get started. After the logo animator JPanel considers the loads the images. Method main set up the window in which the animation will appear, and the line 19 calls the logo animator JPanel start animation method. So which will be declared by the line 76 to 93 of figure 24.4. As showed before, the program stopped the previously. The animation is driven by a instance of class timer. So the class timer is included here because of the user have to merge n number of pictures in one frame. When the program is first run, the method start animation is called to begin the animation. So after merging of these images into one frame, then code have to be given as a start animation. Then the merging of these n number of pictures will be done as one frame. Although we provide that functionality of this method to restart the animation if it has been stopped, the example does not call the method of this purpose. We have added the functionality. However, should the reader choose to add GUI components that enable the user to start and stop the animation. A timer generates action event of a fixed interval in milliseconds. Normally is specified as an argument to the timer constructor, and notifies all its action listens each time an action event occurs. Line 78 determines whether the timer reference animator timer is null. If it is method start animation is being called for the first time, and the timer need to be created so that the animation can begin. On the line 80, set current image to 0, which includes that the animation should begin with the first element of array images. Line 83 to 84 assign a new timer object to animator time. The timer constructs receives two arguments. The delay is milliseconds. Animation delay is 50 as specified in the line 18, and the animation listener that will respond to the time action events. For the second argument, an object of class timer handled is created. This class which implements the action listener is declared in the line 114 to 121. In line 86 calls the timer object start method. To start the timer, once the started command, animator timer will generate an action event every 50 milliseconds. So as we discussed before, it will take 50 millions of intervals of one picture. So for this we need to refer the code from line 117 to 20. So the line 119 calls the logo animator JPanel represents the method to schedule a call to logo animator JPanels. Print command component method, line 64 to 73. Remember that the subclasses of J component. So here if the animation started earlier than our timer which was created, and the condition in the line 78 evaluates to false. So without the user permission, the animation process shouldn't be started. So from program continues with the line 90 to 91, which restarts the animation that the program stopped previously.